Just 56 hours had passed since the Apollo 13 mission launched for America's third lunar landing attempt. The crew, Jim Lovell, Jack Swigert, and Fred Hayes, were about 321,000 kilometers from Earth. In the silence of space, everything was going exactly to plan. That is, until the ship shuddered with a dull, metallic thud that echoed through the hull. An oxygen tank had exploded. The glowing control panels began to dim one by one. Power systems went offline, and at that moment, astronaut James Lovell sent that cool-headed but history-defining message to Houston. This was no longer a mission to the moon. It was a struggle for survival by 3 men stranded in the middle of the void. The lunar module, Aquarius, had to be used as a lifeboat. Freezing temperatures, depleting oxygen, rising carbon dioxide levels. Every passing minute brought death a little closer. Yet, NASA and the crew pulled off one of the most incredible rescue operations in space history. Using the moon's gravity like a slingshot, they managed to fling a crippled spacecraft hundreds of thousands of kilometers back to Earth. Apollo 13 never landed on the moon, but it went down in the books as space history's most successful failure. But what if you had experienced this disaster not in the vacuum of space, but on the planets of our solar system? How long would you last in Mercury's scorching heat, beneath Venus's crushing atmosphere, or in the middle of Jupiter's massive gas storms? Now, it is time to explore the limits of the human body and the most ruthless faces of the universe. How would a human actually die on different planets? Mercury, the closest planet to the Sun and the smallest in the solar system. Here, your fate depends entirely on where you land. Because on this planet, day and night are like 2 different worlds. There is almost no atmosphere, so heat cannot be transported from one place to another. While temperatures drop to -170 degrees at night, they skyrocket to 430 degrees during the day. If you are lucky and land on the dark side, you might manage a short walk with an ultra-protective, thermally insulated suit. Imagine walking on a freezing floor across a gray terrain covered in craters, much like the moon. But if you get romantic and decide to wait for the sunrise, that would be your deadliest mistake. Because here, the sun looks 3 times larger than on Earth and shines with a blinding whiteness. As the first rays begin to illuminate the horizon, the surface heats up instantly. Your safe zone begins to turn into a hellish furnace at incredible speed. Even your most advanced cooling systems cannot resist this scorching heat for long, and your internal body temperature rapidly reaches dangerous levels. Sensors scream alarms. Systems fail one by one. Even worse, once the sun rises, the next night won't come for another 58 Earth days. Fortunately, you won't have to wait that long. Also, the heat isn't the only problem, it's the radiation. Even if your suit could withstand the heat, the intense solar radiation would begin to pierce your suit's armor within minutes. You are now trapped between the burning sensation from within and the radiation from without. Shortly after, your internal organs would receive lethal doses of radiation and begin to fail. Your consciousness would blur, your vision would tremble, and finally, you would fall silently, slowly to the ground. Your survival time here is approximately 15 minutes. Venus. From afar, it looks like a planet shining like gold, but beneath that glow lies a world where even metal melts. The first thing you notice when looking around is that nothing looks clear. The sky is covered with thick carbon dioxide and toxic sulfuric acid clouds. The landscape is bathed in a dense, yellow-orange gloom. Since sunlight barely penetrates here, the planet swims in a permanent twilight. All you see is a barren hellscape of volcanic rocks and cracks. With every step, the soft ground feels as if it wants to pull you in. The suit you're wearing is practically an armored mini-submarine, reinforced with titanium and carbon composite plates. Because here, the atmospheric pressure is 90 times that of Earth. That's the crushing pressure you'd feel 900 meters deep in the ocean. Even a tiny crack in your suit would mean being instantly crushed. But that's not all. Added to this incredible pressure is a surface temperature of around 470 degrees. Lead, tin, and even zinc flow in liquid form here. This scorching heat is the result of a runaway greenhouse effect created by Venus's atmosphere. The planet acts like a cosmic pressure cooker, trapping heat and never letting it out. Your suit is protected by a multi-layered thermal shield made of silicon carbide resistant up to 500 degrees. Inside, a special cooling system works at the cost of your life to constantly absorb and evaporate the heat. When the Venera 13 probe landed here in 1982, it lasted only 127 minutes. Even that metal giant eventually melted and collapsed. Your suit is a much more advanced version, but even it cannot protect you forever. Struggling, you try to move forward across this scorching rocky terrain. Outside, toxic sulfuric acid clouds constantly attack your chemical-resistant tantalum and gold-plated suit. The carbon dioxide around you is in a supercritical fluid state at 90 bar pressure. It is now neither fully gas nor liquid. This dense, almost invisible hell surrounding you is strong enough to crush and destroy everything at any moment. Your cooling system cannot withstand this relentless extreme heat any longer and is the first part to fail. As warning indicators on your visor rapidly rise, your suit begins to heat up like an oven from the inside. There is nowhere to hide, nowhere to find shade. Heatstroke begins instantly. The time between losing consciousness and death is just 1 minute. At that exact moment, the crushing pressure and aggressive sulfuric acid attacking the titanium plates of your suit deal the final blow. The structure heats up, cracks, and ultimately collapses under Venus's hellish conditions. Your survival time on this ruthless planet was only 20 minutes. Even this duration shows the absolute limit of human engineering. Mars. You are approaching the landing site of NASA's Curiosity rover. In the distance, rust-colored mountains disappear into a red mist. The landscape is familiar in a way. It looks like a desert valley on Earth, yet everything is eerily alien. The sky is a pale orange. Even the sun shines a bit dull here, as if it has lost its energy to these dust clouds. But you are lucky. Today is a hot summer day on Mars. You are in the equatorial region, and the temperature has risen to almost 20 degrees. Yes, it's relatively mild outside, but don't feel at home just yet. Because when the sun sets, temperatures will plummet rapidly to -70 degrees. Your thermal protection must be ready for this sudden drop at any moment. Despite your heavy suit, walking feels surprisingly easy. Because Mars' gravity is only 1/3 of Earth's. You bounce slightly with every step. Almost like you are in a dream. You've spent hours on the red planet without serious issues, but don't be deceived by appearances. The longer you stay here, the more invisible threats slowly and silently undermine your health. Mars' atmosphere is so thin that it offers almost no protection against solar radiation. The radiation level here is about 20 times that of Earth. This means every second you spend outside leaves microscopic damage in your body. Luckily, your suit is reinforced with layers of Kevlar and polyethylene. It protects you for now. But remember, the clock is ticking. As hours pass, low gravity and intense radiation continue to slowly damage your body. Your muscle tissues weaken, your circulatory system slows down. Even your brain would begin to feel the effects of this environment. After about 10 hours, your oxygen reserves run low, you feel dizzy, and the warning lights on your suit begin to flash. Shortly after, the signals going to your brain start to scramble. The dizziness gives way to unbearable nausea. You experience severe cardiovascular shock, and unable to hold on any longer, you collapse onto the dusty surface of the red planet. Jupiter. The giant of the solar system. But this giant is famous not for its beauty, but for the deadly environment within its atmosphere. It has no solid surface. Arriving here is, in a sense, a suicide mission. Even as you approach, every system you have screams alarms. Because surrounding Jupiter is a radiation hell thousands of times stronger than anywhere else in the solar system. This lethal energy is scattered around by the planet's magnetic field, which is 18,000 times stronger than Earth's. But your suit is essentially titanium armor. Thick plates and insulation layers protect you. At least for a while. Still, you know what you're facing. In 1995, NASA's Galileo probe dove into Jupiter's atmosphere. It lasted only 58 minutes before being silently crushed by the pressure. Now, it's your turn. The dive begins. In the first layer, about 20 kilometers above the surface, there are ammonia clouds. It's around -100 degrees here. The sky is dark orange. The blue flash of lightning echoes among the clouds. Your suit protects you for now. But as you go down, everything will change. As you continue to fall, the temperature rises rapidly, the pressure builds, and then come those famous Jupiter winds. Massive storms reaching speeds of 600 kilometers per hour await you. You lose control instantly. Your body is too weak to withstand the G-force. Your blood vessels dilate with the pressure, your vision goes black. Within just a few seconds, you would lose consciousness. But actually, your suit is still intact. It doesn't tear even as the winds toss you around. Your unconscious body continues to descend slowly. With every kilometer, the temperature rises by hundreds of degrees. The pressure begins to bend the steel-strong layers on you, and naturally, your story ends while being tossed in the air. Your survival time is approximately 3 minutes. Saturn. The most fascinating yet inaccessible planet in the solar system. With those massive rings, it looks peaceful from afar. But when you get close, you realize this is the heart of a death storm. Just like Jupiter, Saturn has no real surface. Yet, you take the risk and start the dive. Entering the uppermost layer of the atmosphere, the first thing to greet you would be heavy auroras. Similar to the dancing lights at Earth's poles, but much more magnificent, much wilder. As you descend, the temperature drops, the winds strengthen, and hurricanes moving at 400 meters per second kick in. That means winds blowing at nearly 1,440 kilometers per hour toss you like a leaf. Your suit begins to crackle, and you can feel the vibration in every bone cell. What gives Saturn that golden yellow look are the ammonia crystals around you. But even the slightest leak in an astronaut's suit can lead to instant death. As you continue deeper, what surrounds you ceases to be air. Hydrogen and helium are so compressed that the atmosphere begins to liquefy, and you continue to fall toward the inner layers of a gas giant. The temperature drops to around -200 degrees. The outside of your suit would be covered in ice within seconds. Electronics freeze solid. Screens fade into darkness, and oxygen pumps gradually slow down. As the inside of your helmet fills with the fog of your breath, you realize the sensation in your fingers is disappearing one by one. While your lungs gasp for air, with a final reflex, you might look up to see Saturn's majestic rings just beyond your visor. A silent, cold, but mesmerizing view. For a moment, everything would stop. Then, as darkness slowly descends, Saturn would silently swallow you. Your survival time is approximately 5 minutes. Uranus. Far from the sun. It stands before you like an ice-blue sea of silence. But don't be fooled immediately. Beneath that calm appearance lies a deadly storm. The moment you dive into this gas giant, the atmosphere outside begins to thicken rapidly. Winds reach 200 meters per second, that is, 700 to 800 kilometers per hour. As the indicators inside your suit turn red, you would completely lose control, and then the cold begins. This is the coldest planet in the solar system. It drops below approximately -220 degrees. Even the air almost freezes. The outer layers of your suit would start to crack, and the metal parts at your joints would shatter. Even your breath would instantly turn to vapor and crystallize. It feels as if the air coming out of your lungs turns to ice. Your body slows down progressively, and your heartbeat becomes sparse. As the fall continues, darkness would slowly wrap around you. Uranus's serene, pale blue face looks peaceful from a distance. But for you, it is the color of a silent end. Your survival time here was an average of 3 minutes. Neptune. You are approaching the edge of the solar system. Only one spacecraft, Voyager 2, managed to reach here in 1989. Since that day, this blue giant still protects its mystery. The moment you enter its atmosphere, a cold exceeding -214 degrees awaits you. Among these massive layers filled with hydrogen, helium, and methane, the most violent winds in the solar system blow. Their speeds can reach 2,100 kilometers per hour. That is nearly 5 times the speed of sound. These winds would toss you around in seconds. Even if your suit protected you, you wouldn't even be able to tell which way you were facing. Everything before your eyes would turn into a blue vortex. Your suit would vibrate with the screaming winds, indicators giving warnings one after another. Only a few minutes later, the cold and pressure become unbearable. The inner glass of your suit fogs up. Metal parts would begin to disintegrate under the effect of the cold and wind. In Neptune's dark atmosphere, the silence of death would blend into the howl of the wind. Your survival time was approximately 2 minutes. And what about Pluto? Here, the sun is just a bright star in the sky. You land on a surface of gray-white ice hills. The gravity is light, but the air is around -230 degrees Celsius. It's so cold that gases in the atmosphere freeze and fall like snow. Your suit protects you for a few minutes, but at this temperature, even metal becomes brittle. Cracking sounds echo in your joints. A tiny tear is all it takes. The cold seeps in like a knife, freezing your cells. Your breath freezes, your muscles lock, and your heart stops within seconds. The time you could endure on Pluto is approximately 8 minutes. From fiery furnaces to icy tombs, each planet offers a unique and brutal end. It's a stark reminder of how fragile we are, and how precious our own blue marble truly is. Thanks for watching. If you enjoyed this journey, don't forget to like and subscribe for more adventures into the unknown.